Hi, we're a team plugin consisting of Weijie, Kwan Yong, Keith, Kester, and Kirby, and we'll be presenting on our project topic on the Scala programming language and its features in concurrency. We also demonstrate these features by converting some of the exercises covered in AA from Java to Scala. Scala, or Scalable Language, is a modern multi-paradigm programming language designed to express common programming patterns in a concise, elegant, and type-safe way. It smoothly integrates features of object-oriented and functional languages. Scala is equipped with an expressive type system that enforces statically that abstractions are used in a safe and coherent manner. In particular, the type system supports generic classes, inner classes, and abstract types as object members and also polymorphic methods. There is a local type inference mechanism that takes care of that the user is not required to annotate the program with redundant type information. In combination, these features provide a powerful basis for the safe reuse of programming abstractions and for the type-safe extension of software. Scala provides language interoperability with Java so that the libraries written in both languages may be referenced directly in Scala or Java code. And Scala source code is actually compiled into Java bytecode to be run on the Java virtual machine. Scala allows you to express general programming patterns in an effective way. It reduces the number of lines and helps the programmer to code in a type-safe way. It allows you to write codes in an immutable manner, which makes it easy to apply concurrency and parallelism. Before we dive into the features for concurrency for Scala, let us take a look at some of the similarities and differences between Scala and Java. Both are JVM-based languages. Scala produces the same bytecode as Java and runs on a Java virtual machine. Similar to Java compiler Java C, Scala has a compiler Scala C, which compiles Scala code into bytecode. There is the ability to call Scala from Java and vice versa. Furthermore, you can reuse application code and open source Java libraries in Scala. Lastly, both languages support object-oriented programming, while Scala also supports functional programming. With the inclusion of lambda expressions in Java 8, Java is also supporting functional programming in Java. In terms of differences, Java is still mainly an imperative language whereby you have to write out all the steps to what you intend to do. Lambda expressions are just an additional feature to support functional programming in Java. However, many people have actually asserted that Oracle is not changing the language, but merely adding the cool features that people are talking about. Scala, on the other hand, focuses a lot more on the functional paradigm, resulting in much less verbose code that does a lot more. The second difference is that in Scala, objects are always immutable, unless specified otherwise. This is the total opposite from Java, where objects are always mutable. Having immutable objects makes it much easier to handle concurrency with Scala. In terms of concurrency, the Java 8 library provides only traditional thread model concurrency, which is a heavy operation and is difficult for threads to communicate with each other. Furthermore, there may be other issues such as race conditions and deadlocks. Comparatively, Scala uses the actor model, which avoids the problems caused by threading and locking. A way to implement the actor model is through the Akka library, which we will cover later on.
Okay, so now I will be going through one of the class exercises that we have done in Java and convert it into Scala code. And basically for this exercise, we can see that there's actually one singleton object, what we call in Scala, a singleton object, which is called Scala thread, and also another class called myRunnable. So basically, just to briefly mention what a singleton object is, a singleton object is an object which is declared by using object keyword instead by class. And no object is required to call methods declared inside singleton object. Because in Scala, there is no static concept, Scala creates this singleton object to provide entry point for the program. And for this runnable class that I have, it basically extends runnable. And then we have a method run here which prints the current thread over here. Basically, this is how we declare a method in Scala using the def keyword. So this will effectively override the run method in the runnable interface. So now let's take a look at the main method, which is the main thread here. So here what happens is that we create a new thread and then pass in a new runnable task over here called myRunnable. And the difference here is actually the declaration of here, which we can see that actually we use VAL to define a fixed value which cannot be modified. And to define a method, we use def, which I've said just now, and also vra to define a variable file, which can be modified. So over here, basically moving on, we will start the thread, just like how we did it in Java. So it says thread1.start and so on and so forth. Just that now we don't even need to put a bracket over here. And then here we will join all the threads, and finally we'll print program ended. And now let's take a look if this works. So I will just compile the Scala thread, and then I'll run this. Yep, and this works, and you can see that it actually will call the run method in the runnable here.
So now we'll be moving on to something a little bit more difficult. If you guys remember the runner program that we had in our week 2 PP. So what this actually does is that it creates runner objects, and each runner object is a thread. So based on the runner object, they will all be start the race at the start, and the end of the program will actually return the different runners that come in their different positions. So moving on to the Scala version of it, it's actually pretty similar to the Java one. So how this works is that we actually define the class, the runner, and it extends runnable. And this is runnable is actually the Java's runnable, because Scala and Java are pretty much integrated in some way. So this runnable, this is applied to the runner class, and we're taking an integer to sort of uniquely identify the runners at the end of the output. So likewise, we also have this finished, which is equals to false, which kind of dictates whether the runner has finished its X amount of steps, and the steps taken to the starting amount of steps, which is set to 0. So we also have a run method, which actually is the run method that has to be overridden, like any runnable any class that was extended to as runnable. And the code is pretty simple. Basically, if it's not finished while finished equals to false, it will basically take a step forward, and at the end it will actually print out the runner with the ID and finished. So the take set method is basically incrementing the number of steps taken by 1 each time, and basically if the amount of steps taken is more than 500, it will basically be considered as the runner has finished the race, set finish to true, and the program has the thread will actually be finished. So okay, so now we move on to the next part, which is the main object. So within the main object, we actually have an array of threads, which are our runners actually. And yeah, we'll start off with the initialize runner method. So this basically creates all the runners that we have, and we initialize the number of runners based on a number given. And so this for loop actually initializes the runners from with an index of 0 all the way to the total number of runners that we have minus 1. Okay, and yeah, so each runner is instantiated as a new thread. The runnable class is the runnable object is actually placed inside the thread. And yeah, so now we move on to relay. So this is actually starting the race proper. So for each runner, they'll basically start, and we'll start all the runners within this for method. And while the runners are running, we will actually do a dot join to wait for all the runners to finish, and then this thread.u kind of like allows for multi-threading switching, so that the runners don't run in the same order that they don't come in the same order that they were started. Yep. And if in case of any exceptions, yeah, we'll just print out the runners file. So the idea is that within the main method, we basically call the initialize runners to initialize 4 runners, and we start the race with a relay of 4 runners. Yep.
In this method, we are going to demonstrate executor service in Scala. As you can see, I have specified the number of loops that I want my run method to execute per thread, followed by how many task count that I want, which is the number of threads that will run concurrently. One of the advantages of executor service is to run the runnable thread object instead of creating the threads manually, because it has its own overheads, which sometimes are resource intensive, and starting and joining threads are also tedious as well. In other words, we let executor service handle the runnable objects. So in this part of the code, when the execute method is called, the executor service will schedule the task to be run. In this run method, we generate a random number from 1 to 5, which is also the duration for the thread to sleep in terms of seconds. Do note that the sleep is not blocking. So while you ask the current running thread to sleep, you are actually forcefully switching out the thread and put it in time waiting state for the specified interval. So this is also known as context switching. So when the program is run, the console prints task 1 with the iteration 1 that is going to sleep for 2 seconds. So during this instance, the program will not wait for it to end. Instead, it will switch out to another thread to run concurrently. So this actually runs continuously until all the outputs are printed out. So if you do not wish the threads to be switched out, you can actually consider putting a log factory so that the thread who holds the log will execute the complete method before the other threads can actually execute.
Besides threads and futures which we have learned in AA, another option to implement concurrency in Scala is through this toolkit called Akka. Akka is a free and open source toolkit that can be used for both Java and Scala, and it is based on the actor concurrency model with inspiration drawn from the Erlang programming language. The actor concurrency model has similarities to object-oriented programming. In OO, everything is an object, but in the actor concurrency model, everything is an actor. The difference is that actors never share memory, unlike in OO, and an actor's state cannot be changed by another actor. Actors have mailboxes to store messages which are like tasks that are sent asynchronously to each other. These messages will be processed sequentially in the order that they are received. The implication of this is that we do not need to implement locks to tackle race conditions because unlike in Java, actor states cannot be corrupted due to race conditions. Another aspect of the actor model is that it doesn't matter if the actor I'm trying to send a message to is remote or in another system. The benefit from this characteristic is that concurrency can be better implemented by making use of multiple machines. And that brings us to the end of our short presentation of concurrency in Scala. Thank you.